All right, so now, all right, this is what we're really getting to here. How do we set this up for SIENA? Because SIENA's, it's weird in this way. I'm just going to be honest. And there's two ways it's really weird. One is to set up the data. You have to create what's called a SIENA data object that contains all the data you want to use for a model. Okay, so bring it all into one object before you do anything else. And you have to, as part of that, tell SIENA what role each piece of data is going to have. Right? So what is my network? Which is my network? What data object is my network? Any attributes I want to bring in, let's bring those in and tell SIENA that these are, this is a behavior that's going to be modeled endogenously. This is an exogenous behavior that can change over time. Right? This is an exogenous behavior that's not going to change over time. Right? Something like gender or sex. This is a network that's exogenous, right? Like what classes students are in. It's exogenous, but it's going to change. Right? We have to tell SIENA each of these things, specify all of those up front. And so I actually, there is a slide in here. Slide 64 tries to summarize what those are and kind of the script you would use to specify that kind of object. Okay, so we have to specify all of these things up front. So our friendship network is a SIENA dependent variable, and we're putting in this stacked set of networks across 3 time points. Let's see. Okay, so drinking and smoking, we could make those dependent behaviors. Okay, meaning they're going to be in the model as an outcome. All right, this family event is a time-changing covariate. Did the household composition change? A constant covariate, we're going to use drug use at time 1 as something that's static and not changing. You can't, let's see. All right, so we're running all of these. And then we're going to combine them into this SIENA data object with this SIENA data create function. So we put everything in there, all of the variables that we want to use somehow in, or the data objects we want to use as variables. And we'll create this thing, and then SIENA tells us, all right, this is what you've done. You've got 50 actors. You've got one dependent variable called friends. It's a one-mode network. At 3 time points, you've got drinking as an outcome. Right, gives us this short summary of what we've got. Now, we could also set up our data a lot of other ways. Just a network and some attributes. We could bring in smoking as another outcome. The one thing I want to mention, anything you put in here as an outcome or as a dependent variable, whether it's a behavior like smoking or drinking or whatever, or it's a network that you're modeling, the model is going to include that. It's going to try to model that change. And you can't set it to 0 after this point. So whereas we might want to put in every variable we might ever want to imagine modeling, that's okay for things that are going to be independent variables, but not anything that's going to change endogenously. So I might, kind of the back of my mind, I want to put smoking in here because I want to model it, but I want to understand alcohol first. And so let me do a bunch of modeling with just alcohol and the network changing, and then we'll get to smoking later versus trying to do all of that at once. Okay, so a good idea, so there's this more involved report, kind of a set of descriptive output that SIENA will create that is a little bit more descriptive than this, also has some information on the ranges, missing data, the Jacquard indices, some statistics that, or summaries that get used. Well, let me just show you here. If we go to whatever so this will save it to whatever your working directory is. Mine is output. If we look here, it's a text file. Let's see, can I? all right, that gives some of the same summary of the, so this is the data object you just created, and the data object that will be the basis of your model. So this is what SIENA thinks you're working with here. So it's a good idea to check. It gives some degree distributions, numbers of missing data, missing values, means, right? So you can go in and make sure you put the right variable in there, right? You've got multiple variables, right, as you code along the way. Did you get the right one? Did you get the one that treated missing data the right way? So we also have some information here about how much change there is. This is what I want to point out. For some statistics, all right, SIENA will center every variable if you let it, right? It mean centers everything. Just kind of, in general, helps with the estimation. It does this without you even asking for it. So you got to know it centers everything. That means when you're interpreting effects, you have to take that centering into account. How might that have affected it? So it centers based upon, if it's an individual attribute, it centers based upon the mean across individuals. For dyadic attributes, like same smoking or similarity in smoking, it centers across dyads, which isn't so easy to calculate, right? We don't have a mean for that at the push of a button like we do for individual levels. So you can find that value that SIENA is using here in this, right? Similarity on drug, drinking, family event, right there. Yeah, okay, so there's drinking. So, so you might need to pull that out for some interpretation steps later on. So that's where you find it. This will also give you, I mentioned the Jacquard earlier, this will give you the Jacquard as well as how much change there is and what types of change there are across the two waves, as well as changes, distributions of behavior and changes in behavior and the nature of change across time. Okay, so there's that. All right, now the other weird thing about SIENA is that to specify effects, we're going to create a separate object that is the effects we want in our model. Okay, and here we're going to call that myEffects. And what it's doing is it's applying this getEffects function to this SIENA data object that we created earlier. Okay, so it's going to look at that object. It's going to do that. And then if we look at what myEffects is, you see it's, it looks like it's 8 effects, a couple of rate effects, out degree reciprocity. It's got effects here for predicting friendship, and then effects here predicting drinking. Okay, so these are our two different functions, right? Totally different outcomes. Right? This is one outcome. This is another outcome. Okay, these are the effects that are currently in that we could use to estimate our model. Now we want to add more, right? We want peer influence. We want homophily at a minimum. This step up here actually created a much larger data table that we don't see. And that you can see it by running this effects documentation. And it pulls up this table that the idea is that these are almost every possible effect that one could estimate given the data that you entered. Right? So it's a whole host of network kinds of effects, right? Things like reciprocity, transitive triplets, different versions of transitive triplets. You'd want to look at the manual to see what those are. 3 cycles, transitive ties, balance. There's like 800, right, effects in here. Right? Some of them are these network-based things. Some are, let's get down here further. Okay, so some are based on drug use. And let's keep going. Drinking, all right. Some are based on drinking. Some of these are, if we look over here, this column. Some of these are for creating ties. Some of these are for maintaining ties. Some of these are if we're kind of constraining those to be equal, right? So there are hundreds of different effects we could choose, okay? To actually choose an effect, we're going to use this column over here that says short name is kind of a unique name that specifies a particular kind of effect. So for instance, reciprocity here, transitive trip, right? It specifies a particular effect. And then we're going to, for some of these, combine that with other information here. So let me scroll down here. You know, we've got drinking in the model, or drinking in the data, drugs. We've got family event. For drinking, we're going to end up using something called same-X or sim-X, which is, are people the same in their drinking? Okay, well, we've got a same-X effect for drinking. We've also got a same-X effect for every other individual attribute. Right? So we're going to combine same-X with drinking to create that effect. Okay? So what that actually looks like in our model is we're going to do something like this. Okay? We're going to take our myEffects object, which is the set of effects we want to include in our model, and we're going to specify which effects get included. Okay? And we're going to identify an effect. AvSim is a similarity, a peer influence effect. Okay? It is going to be based upon friends, so it's similarity among my friends. This could be other networks if we had multiple networks. And it's going to be predicting drinking. Okay, so we would run this. And then if we looked at this myEffects object, we're going to see now for the drinking function, we have this thing called drinking average similarity, and it's included as part of our model. So what we're doing in steps like this is we're going to this massive table, and we're figuring out the rows that correspond to the effects we want to include, and finding that row and kind of checking it as, okay, include this one. And there's actually, I don't know if we can see the column here. There's a column in here that is that indicates which of these are actually included when we estimate the model. All right, so 800 possible effects, some small subset actually get included when we estimate the model. We can actually look at this thing. Let me set up a few effects for some different things. All right, there's some effects. We can actually look at that. The fix brings up a table here. You're going to have to bring it up because I know you can't. I can barely read this. But there's a column here, include, that lists, okay, which of all these effects are included. Include is true, not include is false. Most are false. As we're setting up the model, we're going through and checking these as include. So one of the, we have to stop this to be able to view. So one of the challenges is figuring out how do you specify this include effects. And if you think that what I'm trying to do is figure out what row in this table do I need to include, I need to have the outcome variable, I need to have the right kind of attribute if it's based on an attribute, and this short name here to refer to the effect. I need that combination of things that will narrow it down to just one row. Yeah.
How do you assess or account for like multicollinearity with the effects you're choosing? Would you run those independently before you chose your effects, or is that something that you're just interested in like the summative account of like we don't really need to separate out all these different instances, we're just trying to see if these things are changing?
Yeah. So I'd give two answers. One is kind of theoretically, kind of trying to capture the main things that you think are happening. and not, and so the multicollinearity might come in with something like peer influence, where there's different ways of specifying, and you want to test all these different ways of specifying, and that's a very real concern there. So there are two things, a couple strategies. One is, and this is just a general good strategy, is engage in a forward-fitting modeling approach, where for an initial estimation, don't put everything in there that you want to test. Put in like key effects that you know are strong, and kind of slowly build up the model, and dropping effects that are possible controls, but don't really end up mattering here. So build up the model, and then so if it's something like I want to test a bunch of different ways that peer influence might work, it's probably not going to work to put them all in there at the same time. The way to detect multicollinearity is the model explodes. It just doesn't converge. And so you can do a couple of things. So you can test, there's a score test for prospective effects. So you can imagine estimating a base model, and I want to test these effects. Let me score test them, which is basically saying don't include them, but figure out how much would they improve fit if they were added. And you get back a chi-square value that can tell you some of these look like they would really improve fit, some would not. Gives you some direction. You could then include them and evaluate them. You could, like, again, for peer influence, if it's not too many, you might try a couple of different variations in the same model, and you may have the power for that. I've maybe once been successful in that, but oftentimes, yeah, it does. You do run into that multicollinearity. But score test is the main thing to be thinking about. I should get a model going while we're talking. Are there other questions? Yeah, go ahead.
When you run the effects documentation call on the data object, how does SIENA determine what effects are available to include in the model?
Where does that list of 800 come from?
Yeah, well, because there's an effect from a different script. Like I have our script from my advisor, and he has an effect that I want to include, but it's not available when I look through the effects that are available from the data object. So what is this?
Okay. So it could be two things. It's possible if you don't have the latest version, it could be that new effects are added all the time, and it could be that. It could also be some effects. There are probably just as many interactions that you could create. So it might be that's an interaction, and there's a way to specify some of these effects will go together. So something like homophily, you could interact with maybe like transitivity, and that would be a custom effect. You take these effects that exist and just say put them together. Maybe it's that.
I can say that the short name is effect from, like EFF from, and I have it available for.
That's pretty amazing. That should be in all of them.
Well, I have it available for identity covariates.
Yeah.
So gender and race, but I don't have it available for the network. So what I want is the effect from the network on my behavior dependent variable.
Okay.
And it will
Okay. Let's talk later then, because there's a few different ways the network could come in. All right. I think it ran that. That never happens. You never see a model run so fast that it's over before you know it. Okay, so let me just run this again, because I want to point out just a couple of things while it's running. This screen pops up, that's SIENA. These are how the parameter estimates are changing for your different effects. These are kind of correlations between jumps from effects, right? SIENA is trying to go from what if reciprocity is a 2, right? How does the model fit? What if it's a 2.1? What if it's a 1.9, right? It's jumping around for reciprocity and everything else in the model. And What you want is eventually those jumps get smaller and smaller, so these get closer to 0 and 0 and 0, which is a good fitting model, or promising. If these get really, really big, or these get really, really big, just stop. Your model's gone haywire, and it's not going to fit. Okay, so you can, these things are, for a decent sized model, this could be 2 hours to 48 hours for a model. I mean, it really is. So if you can nip some problem in the bud, you want to do that. So the other thing I want to show you is, in looking at the results, first thing to check, this convergence ratio. Right, did the model, this should be less than 0.25, right? If it's not, run the model again. You can take the current estimates as starting values, run the model again, get decent convergence before you start trying to do anything else. You've got convergence ratio overall, and then up here, you've got convergence for specific effects. It could be that if you don't have good convergence, it could be one effect that's problematic, which could be a sign of multicollinearity. You might want to pull that out and try again. Okay. All right. I think I'm out of time here. So. Well, I think we probably need coffee, but all right. So I'll just mention. How about get coffee? I'm going to a couple of concluding notes. And then I'm happy to answer questions anytime after the workshop as well. Let's see. You know what? I might have gotten through. Okay. So, well, I just want to mention there are like hundreds of things I couldn't cover. So this tries to mention some of the directions that folks have moved in, and some of these are now totally possible. Some are still in development, but there's a lot of flexibility in terms of thinking about how different processes come together, different objects come together, different behaviors come together, different ways of thinking about influence. I mean, it's kind of a goldmine of opportunities. So. Yeah, so much that it can oftentimes be daunting. And I think one of the more daunting things is what do I put into a model? So I've tried to put some examples of what we try to put into a model. Looking at the literature, right, is one of the best ways to understand for networks like mine, whether it's friendships or something, what are the kinds of things that people control for? What are the kinds of things that are important? And then kind of using your own network intuition to figure out, well, how does that work in my case? Okay. So, all right. So last thing I'll say, we have peer influence on drinking, which was where we ultimately started. We have homophilous selection on drinking. We don't get p-values here. We'd have to do some steps to get some p-values, but you could basically take the estimate divided by the standard error. These are you can think of a t-distribution, so these are about twice their standard error, so we just barely have enough. With 50 folks, that's not surprising. So it must be pretty strong if we're able to pick it up among 50 folks. We could do some additional steps to figure out how much, like how important is the selection versus influence in driving similarity, right? We don't get too much insight here. These are on different scales. And so this could be 90%, selection, 10% influence, or it could be the other way around. So there's some further slides that talk about using the SIENA, the simulation capabilities at the heart of SIENA to do some kind of further work to try to understand the implications of the model. So kind of one thing would be to decompose how much each of these is driving the observed level of similarity. All right, so I'll let you have coffee now, and please let me know if you have any questions.